Right, we're looking for the length of this line here, BC. What's the length of this line here? Find BC, the length of BC, correct to 2 decimal places. Well, what do we know? We know this angle and this angle. The three angles in a triangle add up to 180. So this guy and this guy add up to 152. So 180 minus 152 equals 28 degrees. So we can write in 28 degrees there onto our diagram. And now we want BC, so we know the opposite side to BC, so we know that's 16 meters. Let's see, what else do we know? BC. I had this done already, so I should know what I'm doing here. 28. Now we know the triangles. We know this side. Oh yeah, well you see this side 16 meters pairs with the opposite angle is 110. And we have a situation like this, we're going to use a thing called Sine Rule. And this is 42, and that's paired with its opposite side, BC. The length BC. So the Sine Rule works like this. You'll find it on page 16 of the tables, and there it is there, right? The baby letters, the small letters, are the lengths of the sides, and these are the sines of the angles opposite those sides. So we can say, using the Sine Rule, that BC over the sine of 42 degrees equals 16 meters over the sine of its opposite angle, 110 degrees. So sine 42 is just a number. We can multiply this guy here, this side of this, by sine 42, and we'll get something like sine 42 degrees multiplied by the length BC on top, and we still have our sine 42 below, equals 16 times sine 42 on top over sine 110 degrees. And the reason I did that was because I know these guys are going to cancel, and we'll be left with BC equals 16 times sine 42 over sine 110 degrees. So the calculator will take all that there, using the fraction key, 16 multiplied by sine 42, close the wee bracket, all over sine 110, close the bracket, and press equals. And we get 11.393, and that's meters, and to 2 decimal places. We look at the third decimal place after 1, 2, 3, that's low, that's less than 5, so this 9 doesn't change. So we get 11.39. So BC is 11.39 meters. And there's probably 10 marks going for that. 25 marks there. Probably 10 marks going for that. Then we're looking for the area of the triangle BCD. And where is this triangle BCD? So we B, C, and D. So we're looking for this area of this triangle. We know that this side here is 11.39 meters. We know that that's 16 meters. So we know quite a lot about, we know the triangles. So looking for the area of a triangle, here's a formula on page 16 of the tables. Area, half AB sine C. C is an angle, A and B are the side lengths. So look at this, we have the angle sandwiched between A and B. So using this half AB sine C, area equals half A, B, and sine C, that's C, 28 degrees, half, so half multiplied by 16 multiplied by 11.39, so that's a half AB multiplied by sine 28 degrees. So we'll bang those guys into the calculator. We have 1/2 times 16 times 11.39, so that's our two sides, times sine 28, close the wee bracket and press equals. And that's our area there in meters squared, 42.78. Let's go to 2 decimal places. That's what they're asking for there. Because this 8 is 5 or greater, it causes this 7 to go up 1. So we get 42.78 meters squared. That's the area. Finally, part B, we're asked to find AB, the length of AB, correct to 2 decimal places. Well, here's A and B. The distance between these 2 points is called AB, and we're looking for that. And what do we know? Well, we know this side length here. This is the other triangle here now. We have 16 meters, 10 meters. Do we know this angle? Well, we can work it out, because this is a straight line here, and a full rotation around D there, like this, that's 180 degrees. So to get the guy in the middle there is going to be 180 minus the 63 and minus the 42. And that'll give us our angle in here, marked in green. So we've 180 minus 63 minus 42, 75 degrees. So that's our angle there. So we have these two sides and we have the angle between them, and we don't know this side. And in this situation, we're going to be using, also on page 16, a thing called the cosine rule. And we can see that the length of side A is equal to the length of side A is equal to the square of the length of B plus the square of C, C squared, minus 2 times the multiplication of the lengths times the cosine of the angle A, capital A, which is opposite side A. So in our triangle in the question, we have these. We have a side and the angle between them opposite to this unknown length. So using cosine rule, A squared equals B squared plus C squared minus 2BC cos A. In our particular example, A is the length we're looking for. B will be 10 meters, C will be 16 meters, and big A will be 75 degrees. Now we can further make this a little bit more useful by taking the square root of both sides. So with the square root of this side equals the square root of everything on this side. The square root of a square, just these guys cancel out each other. The square root cancels out the floating 2 here. So we end up with A equals the square root of B squared plus C squared minus 2BC cos A. And then we just fill in from our particular case here. So that's going to be the square root of 10 squared plus 16 squared minus 2 times 10 times 16 multiplied by the cosine of 75 degrees. And we'll just put that all into the calculator nice and carefully. So how do we do that? We press our square root sign, and we have 10 squared plus 16 squared minus 2 multiplied by 10 multiplied by 16 multiplied by cosine 75 degrees. That should do it, hopefully. Press equals. And we get 16.528. That's the 3 decimal places. We're looking for the answer to 2 decimal places. Because this 2, or because this 8 which sits in the 3rd decimal place is high, it'll cause this 2 to round up to a 3. So we get 16.53 meters, and that's the length of side AB.